back to morning. So, good morning, ladies and gentlemen, and thanks for coming out to InterTarget Communication in Actor Framework. I'm your host today, Alan C. Smith. I have been writing LabVIEW code for, well, this summer will mark 24 years, which is a long time. I've been a CLA since 2004. A lot of folks probably know me from my time at National Instruments. I spent 6 years in systems engineering. That wrapped up fairly recently. Posted a lot on the forums on Actor Framework topics. I was kind of the Actor Framework evangelist. In that time, my forum posts were all under the heading of NIACS. Now I'm out. I'm no longer with NI. I'm an alliance partner and a consulting software architect, and now I am just ACS. So you can go find all of my posts and stuff there. Okay, so what am I going to talk to today? Well, InterTarget Communication with Actor Framework, and what your options are. This session is really about acquainting you with some packages and toolkits that are available that you can download today and start doing cool stuff with talking between two targets in Actor Framework. We'll do a little background, make sure we're all in the same place, and then I'm going to talk to you about linked actor trees, client-server connection that's using nested endpoints. Those have been around for a while. They're actually covered in the Actor Framework course if you take that. And fair number of downloads, fair number of views, fair amount of feedback on them. I'm also going to talk to you about a couple of options for having a single actor tree that spans multiple targets. Instead of being two trees that talk to each other, it's just a single tree. That's gotten a lot less attention, but we can do some really cool stuff with it. And I'm hoping to get you guys excited to try it out and use it in your projects and see what we can do. Our two options there are something called caller endpoints, and then something called the launch remote actor package. Hydrate the presenter. All right, a little background. I'm going to guess that everybody here has at least heard of Actor Framework and has some sense of what it's for. Anybody? No? All right, cool, awesome. So I can get away with the single background slide on Actor Framework, which of course is a framework for building high concurrency systems, lots of parallel processes that talk to each other. You build systems out of actors, which are parallel threads with data and functions, and of course they exchange messages to do their work. Sounds an awful lot like queued message handlers, which they're actually derived from. It's an object-oriented framework, so we leverage inheritance and composition and all our good OO techniques to build complex systems. One of the value adds that I'm not sure gets talked about enough is that it is a common framework. The idea is to encourage reuse and collaboration. So I can write you an actor that solves a problem that we all have, and I can share that with you, and you can drop it into your application, and you can use it. And if you don't like it, you can write your own. But the idea is that we all collectively, as practitioners of Actor Framework, can be helping each other with these common problems. It's hard to write. We all are working in our domain spaces, and we have reused code for us, but it's hard to share that. These kinds of glue functionalities, though, are actually really, these are the kinds of things you could write and share and leverage. So I'm talking about add-ons for this particular problem and ones related to it. This is probably the most basic degenerate case of I have a PC and it's running an application, and that application needs to reach out to my compact Rio, which is also running an application, and exchange data with it. Like I said, this is probably the most basic on the NI platform. Certainly not the only one. Often there will be several C-Rios, for example. They can be PXIs, they can be other desktop computers. It can be any mix of these things. These things can be sitting on a table in a lab somewhere, or they can be halfway around the world from each other. It doesn't manage the same problem, and not significantly more complex than this. So we can look at this one and focus on that, and I can communicate what I need to communicate to you. This, of course, is Actor Framework on a single target. Right? You'll have some launcher app that'll fire off your top-level actor. Your top-level actor will launch some child nested actors, and those nested actors will launch nested actors, and so on. You get this nice tree hierarchy. Messages go up and down the tree. Callers talk to nesteds, and so on. So that's a really well understood problem. It gets more exciting, of course, when we have two platforms, because now we are talking usually about 2 separate applications. And our communication is complicated by the fact that Actor Framework relies on queues, and queues don't work between application instances in LabVIEW. So we have to put something in that spot. It's usually TCP/IP or UDP or network streams or something like that. And in fact, that's what's been done. In the past, we've had several solutions for this, a couple of them over the years, and we basically borrowed from Actor Framework comes from Cube message handlers. So we were able to borrow the solution that the Cube message handlers use and wrap it up in an actor space. And that is, we make a couple of actors that sit down at the bottom of our 2 actor hierarchies, and they create a network connection with each other and trade whatever data they need to trade. We shipped Actor Framework, when I was with NI, we shipped Actor Framework in 2012, officially. And right around that time, I produced and released the linked network actor, which I'm going to be discussing briefly. That was a first cut solution to that problem. Lots of people downloaded, lots of people liked it. The forum page on the linked network actor, the comment section is several pages long. Lots of people got use out of it. It was bidirectional, so you had to have one actor on your system to send and receive messages. It used network streams, which a lot of people liked. And it was persistent. You launched the actor, the connection actor, and it stayed open and running for the duration of your application. And we put it out in the field, we started using it, so we had good results, and also found it was all new things. There were some things we really needed, like TCP/IP. Network streams and firewalls don't play well together. Not without making your IT guy really, really cranky with you. So we needed to support TCP/IP. And it was kind of funky, to be honest. If you wanted to send a message, you had to take the message object, package up its data, and then that whole message had to become the data of this special transmit message. So you would tell the linked network actor, please, I put a message in an envelope for you. Please open that envelope and send it across the network. And it was just kind of a drag. It wasn't very actor-like. And so we worked on something else, or I worked on something else, and as of, well, a while ago, the linked network actor is deprecated. It's the whole reason I brought it up is there may be some folks who've been using it, and I want you to know that it's still there, you can still find it, you can still download it, you can use it in your applications. No further work is going to be done on it. Because I have something better. What do I have that's better? Well, what I have are nested endpoint actors, which are sort of the next generation linked network actor, if you will. They're similar in how they work, but how you use them is different. And these make connections between 2 actor trees. They're very client-server kind of connection where I'll have my target process on one side, and it's always there. And I've got my UI that wants to connect and disconnect, which is why I refer to as client-server. This is 2 network. It's the same thing we were doing with the linked network actor. It's 2 actor trees. We're linking them way down here at base level, but the trees are completely independent. So nested endpoints, why are they better? Well, they support TCP/IP, first and foremost, as well as continuing to support network streams, as well as allowing you to write your own protocol or to use your own protocol. As long as it'll fit in the API, you can take whatever you want to do, so, drop it into this architecture and use it. And so it's very extensible. We got rid of transmit message, found out how to do that. We got changes to Actor Framework that made it so you can just send any message to your network link and it will be forwarded. There's no special transmit anymore. And to streamline it even further, it's no longer persistent. If you want to connect, you launch a nested endpoint. If you want to disconnect, you tell your nested endpoint to stop. Much more actor-like. Starting to get away from the notion, hopefully not many people still think this, but at least initially there was the perception that your actors ran the whole duration of the application, and that's not true. So it really is appropriate to have these ephemeral actors that you launch them, they run, when you're done with them, you make them go away. They're there for as much as you need them and no longer. And nested endpoints are built around that idea. This is UML for the nested endpoint. You can see the laser. So the TCP stream and network stream, those two protocols are just wrapped up in a thing called a message stream, which is a real simple 4 VI API, connects, send, receive, disconnect. Real straightforward API. If you can fit your protocol into that, you're golden. Nested endpoints are a type of network endpoint. I'll talk about that in a moment. Right now we're just looking at nesteds. But the nested endpoint does all of the, manipulates that API to be able to move data from that API into actor space and back. So it does all of the, this is when we connect, this is when we disconnect, this is how I receive messages. Using them is very, very simple. You just cube drop a nested actor onto your block diagram. You configure it with the type of protocol that you want to use, and you launch it as a nested actor of whatever's going to use it, hence nested endpoints. You'll note that the TCP stream is actually, in this case, is actually a listener. There is an initiator counterpart. So one of your nested endpoints is going to get launched by that server side. It's going to be sitting there waiting for a connection, and it would launch a TCP stream listener. The intermittent caller, client is going to launch a TCP stream initiator when it wants to connect. That bifurcation is specific to TCP and network streams. If you come up with a different protocol, or you want to use a different protocol, that can be, that doesn't have to have this, it's not required, but that's how the TCP and network streams need to work. Just a little bit of what's under the hood on this. Nested endpoints have an actor core override. The actor core override has the message handler that we all know and love. It adds a helper loop whose job is to receive these TCP packets. That's what we use helper loops for, is to take something from actor space, translate it back into actor space. So our two applications launch. When the nested endpoints spin up, the initiator will reach out and connect to its counterpart across the network. Once that connection has been established, message traffic can move, send to nested endpoint, it takes that message and forwards it. It gets counterpart's receive loop, translates it back into a message, passes it back to its caller. And of course, that, as I said, bidirectional. Not all messages are forwarded. These three are not. If I'm relying on the stop message to stop my nested endpoint, I probably shouldn't forward my stop message to my remote. That would be bad. Nothing would ever stop. So stop is handled locally. Report error. I use report error within the nested endpoint to actually check for certain error conditions, so I can't forward that one either. And then finally, for reasons that will be clear shortly, I don't forward last stack either. Last stack is handled locally. For those of you who are curious, this is done on a receive message override for nested endpoints. That's what receive message is for. You can go, it's straightforward code to go poke around. Or find an offline on a huge. So, that persistence though, this is really cool. You still need, if your client server and the client disconnects, well, the server needs to reset its connection somehow. We need to have some persistence, but we don't have it in nested endpoints. So how do we manage that? You can still get it. Who here has done anything of interest with handle last stack? You've overridden handle last stack core, and you've done something cool. Sam back has done it, Eric's done it. I got a couple of hands around the room, and I know most of you that have done it. You must have had conversations at some point. Okay, for those of you who are using Actor Framework and you're not doing stuff with last stack, you need to take a good hard look at last stack. It is the unsung hero of Actor Framework. You can get so much, you can do so much to clean up your code by looking at last stack and what it does for you and figuring out how to use it to simplify your actors. And this is one example. So last stack is a message for those of you. Who's heard of last stack? Who's familiar with it? Okay, good. More of you are familiar with it, just not using it. For those of you who didn't raise a hand, all actors in Actor Framework, when they terminate, assuming they started correctly, will send a last act message to their callers. It's just another message like anything else in Actor Framework. That message, that the calling actor will receive that and can respond to it. My actor has stopped. I need to do something. You get some data that comes back. You get the final error state of the nested actor. You also get the entire final state of the actor. You get the actor itself back, the cube, with all of its final state data. Okay? And in the case of, say, our nested endpoints, the only configuration data in a nested endpoint is its connection information, the port it's supposed to use, and the remote that it's supposed to connect to, its address. That's all you have to configure when we still have it. Therefore, get your last stack. This is an override of handle last stack for, get your last stack, read actor to get that actor cube, and you pass it right back to launch nested actor. So just like that, the act of, nested endpoint shuts down, caller goes, oh, my nested endpoint shut down, I'll just start it. And it's that simple, and it's already, the hooks to do it are already in the framework. So please, 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 read up on last stack. It's truly awesome. Now, yeah.
Does that still work on like a physical disconnect? Making a last stack over the network?
Last stack doesn't go over the network. Last stack's handled locally. So your okay. So the nested endpoints, when the remote disconnects from you, that will cause you to stop. But when you stop, you will send the last stack to your caller, normal traffic. The last stack doesn't go across the network. So is that a hand? No. Okay. Like to cut out of the corner of my eye. Answer your question? Okay, cool. Now, I wish everything was this easy. I wish this was this easy. It's not quite that easy. You do have to do something. You have to write your code intelligently. You do have to do proper decoupling and stuff that I know is actually really fun, really close to John's heart. I'll tell you why this is important. It's not hard, but you need to be aware of it. So here I have two projects loaded into memory at the same time. And in case you didn't know, two projects in LabVIEW, that's two instances of LabVIEW. Okay? That is exactly equivalent to having one project with a host and target. As far as LabVIEW is concerned, they're different spaces. You can't talk between two projects, for example. Project on my right and your left, there's a host class, and then there's it invokes another process, which is another actor called another process. Original name there. They also use nested endpoints. And on this side, we've got a target, and the target has a nested. Okay, so I have two actor trees. They're all statically linked together. Everybody's connected, right? There's no connection between the target, the projects, of course. And then I go say, all right, so host needs to send a message to target. How do we do that? Well, it's actor framework, right? We go off and we grab the send VI from the message class of interest. We drop it on the block diagram of a VI in host, and that's awesome. And then what happens? Well, why are these all locked up? Why is target locked? Because target is linked to its message. And when we pull in the send VI, we've linked host to that message. Target and host are now linked. The target has been pulled into the dependencies of the host side. The target gets locked. Target's messages get locked. And the nested gets locked because nested is called by target. Okay, well that's drag, right? That's a problem. And of course it's a bidirectional problem because the moment target tries to send a message to host, we do the same thing, and unsurprisingly we get the same result, right? So we're not insane. Host gets locked, host messages get locked, the process gets locked, and it's worse than that because I can pretty much guarantee you that something on the target side, if that's an RT target, it's calling some code that's prohibited on the host side machine. And I can guarantee you that the host side is calling some UI code that's prohibited on the target machine. And so not only is my entire project locked, but it's broken. Yes! This is a good thing, right? No, this is bad. This is in fact intolerable. I've had friends say this word isn't strong enough, but I'll go with proper British understatement and we'll go with intolerable. And so let's not do that. Let's do something else. And let me tell you what that is. You have to do a little design work. And what you need to do is you need to introduce an interface actor into your system. Okay? That's these guys. The interface actor is a, in front of those interface actors we will derive some local specific code, but those like that remote UI and UI, remote proxies of each other, they pretend to be each other, they have a common interface. The interface actor, those of you who've taken the actor framework class or studied, this is what we call a low coupling solution. The interface actor is an actor with methods, right? All of those methods are dynamic dispatch, okay? And then it defines messages for those methods, but the methods don't do anything. If you send an interface class a message, nothing will happen. The interface actor receives every message that crosses the application boundary. You might think that's not true, but you actually have to have them all there for reasons I'll be clear shortly. So in this case, for this example, I've got a set of 3 messages that are for the host. They come from the target to the host. And then I have to have one more message that goes from the host back to the target. Okay, one interface class, complete set of messages. At least the ones that I want to cover for that interface. Then we take that interface class and we make children of it. We make one child on each target. Okay, the children override parent methods of the interface to either, oh, I've received this remote message, I need to act on it locally. Okay, so I'm going to invoke some local code to update the UI, or I'm going to forward this on to something else that will use the data. If the interface class has received a message, receives the message locally, like from its caller, then it is going to send that message down to its nested endpoint and off that goes. And that's why the interface class has both sets of messages, as the complete set of messages. It has to do something intelligent, handle it or forward it, regardless of which platform it's on. Okay, the children, the remote proxies, we use them to solve a local problem. So, either the remote proxy is either going to be like the UI and it'll be the end consumer of the data that's received from the remote, or it's going to be, the nested actor of some other caller, and therefore it just exists to forward data along. And there's okay. There are probably other combinations, even too. Should I use this? There we go. I dropped a slide. There it is. No, wait, got it. Okay. This, breaking it up in this way, where the interface is just to find some messages, and then the 2 children call the target-specific code, that suffices to take care of almost all of our coupling. Can't make it all go away. Nested endpoints will still be coupled, but you shouldn't need to touch nested endpoints because that's a package that you download, and somebody else maintains that for you. If you write the equivalent or something similar for your organization, again, that is presumably your reuse library, and that should be manipulated separately from whatever project you're working on. So you don't have to worry about that when you log. We'll have the interface class still gets locked, but we don't do real work there. So if you need to modify the interfaces, close the projects down, change the interfaces, open the projects back again, make whatever change you need to make in your remote proxy. It's not perfect. It's not I can work on whatever code whenever I want, but it is significantly better and very much more manageable. All right. Last thing you need to do with nested endpoints. Presumably at some point you're going to go build an executable of your application. I hope. Really, I hope you do. When that day comes, you need to make sure that all the message classes your remote proxy receives remotely get loaded. The ones that you receive locally, somebody else on your local target is linked to, and they will be guaranteed to be loaded, and you're all good. But it's not true for the remote stuff, because the only thing that forces a message class into memory is calling that send data. And you're going to call it if you're getting it from the remote. So, to make sure they get loaded into memory, you have to cube drop. You have to put the message class itself as a constant on a block diagram somewhere in your system. That's the slang term for dropping message classes, cube dropping, if you haven't heard that. I love the phrase. So, cube drop that right there. A really good place to do it is you're almost certain to have an actor core on your remote proxy. There might be some cases where you wouldn't, but I'm hard pressed to think of one. So drop them on a remote proxy. That's the place they're getting used anyway. And so you know these are the ones I expect to get. It's also sort of self-documenting. These are the messages I expect to get remotely. And then when you build your executable, that'll guarantee their full deployment. Okay, so that is a So that's a reasonably complete and successful solution to this particular challenge. I've got the intermittent connection of something to something that's running all the time. I've got 2 active trees that I want to connect. Lots of people doing this. We've had a lot of success. Nested endpoints, get a lot of good comments on your webpage. But I still kind of, I would still like to have a single active tree. It's still 2 active trees. And there are circumstances where what I really would like to have is just 1 active tree that spans a couple of targets, or 15 targets, or whatever. I still want this, where I'm going to have something running on the target for sure, but I would like the whole message chain, everything on that, to be from caller on one target to nested on another. Can we do that? Why would we do that? So the answer is yes, we can. Now let me tell you, take a little bit of digression and give you an example of where you might want to do this. Matt Pollack was actually talking about this in the previous session, if anybody was in here. So one of the last things I worked on at NI before I left was a continuous integration project. We're figuring out, okay, how can we make Jenkins talk to LabVIEW to build, to test and deploy applications? And one of the solutions that we hit on was we make a web service that Jenkins could call, and this web service would be written in LabVIEW. And you could invoke the web service, and you could do your VI tester calls, and you could do your builds, and you could do whatever from that. Well, Jenkins would really, really like that web service to always be there. Wants to reach out and make that call. It's continuous integration, but always needs to be present. That argues for 24/7 operation. That argues for an executable to make it all nice and neat and orderly. A couple of problems. Can't do a LabVIEW build from an executable, not permitted, specifically blocked. And it's really handy when you're doing these automated tests and automated builds that every one of your steps starts from a clean launch of LabVIEW. So you don't have any extra code working in memory to get cross-linked into whatever you're trying to build, and therefore invalidate your build. So part of this application needs to always be there, and a part of this application needs to come and go as we need it. We want this. Okay? So the web service is sitting there, and it's got some actors that are always present. It gets a call for service, and it launches whatever code it needs to launch locally to start that job, and that's going to reach out across the application boundary, okay, into the second LabVIEW instance, and launch it, reach into it, and start, the actual job and do the job. And then when it's done, it's going to roll it all back up and put it away. And that's what we want. That's very actor-like. Actors should be, actor systems are not always up and running. They're going to have actors that come and go. That's what we want. How do we get there? How do we get this PFM? Killing me here. What's PFM? As my wife would say, it's pure freaking magic. Okay, what's the magic here that'll make that go? Okay, this thing on. All right, so we want that. We want to know what goes here. And I have 2 solutions for you. And there may be others. I'm sure there are others, but here's 2 that you can try out, this afternoon. And the first is caller endpoints. What's a caller endpoint? Well, a caller endpoint is related to a nested endpoint. They have a common parent. Okay, caller endpoints use all of that network endpoint stuff that I was just talking about. Okay, still uses our TCP stream and network stream or whatever you want to write. Still manages the same connect disconnect protocol, but they're structured just a little bit differently. Caller endpoints, the one I'm going to talk about next. Again, not used often. I'm hoping to excite some interest here. So what a caller endpoint does, a caller endpoint says, all right, great. I still have to have a host and a target application. I can't get away from that. This is what I had before. Host and target would launch their processes, and they would launch their nested endpoints and connect. Caller endpoint's a little different. There will be a target application sitting there with a caller endpoint running, waiting for a connection. The host is going to launch whatever it needs to launch, in this case a UI. The UI is going to launch a nested, so a caller talks to a nested. 2 callers might talk to each other. That would be really interesting. The caller talks to the nested. The nested is going to reach out, connect to the caller endpoint, and that acts as a trigger for the caller endpoint to be the caller of a tree of processes. The target application really doesn't interact with anything here, except probably just restart the caller endpoint when you're done. That's your message traffic. It's going to go exactly like you want it to do. It's very, very actor-like. something I was going to add there, I just slipped my mind. I'll come back to it later. Oh yeah, so when we wrap these up, of course, the sub-process stops, and the process stops. The caller endpoint will then stop. It'll handle that stack by stopping, forward the last stack onto nested endpoint, which will handle the last stack by stopping, and all of this will shut down the way we expect it to, and then we can turn it and restart it. The caller endpoints are about as easy to invoke as a nested. The only change is that you do have to tell the caller, hey, you are launching this actor. When you get a connection, launch this actor. Okay, it's really the only difference. Minimizing coupling works the same. Okay, you're still going to have interface classes, and you're still going to have remote proxies. Where they plug into the hierarchy is a little bit different, but not much. You'll do the same code work, and it will look very, very similar when you're done. So that's caller endpoints. Your other option. I wrote this and applied it to the CI web service, and we actually got that working, but it was something else that I wanted to use that was available at the same time, but it required an experimental fork of actor framework. You can't use that in a build system. But we worked that problem out, and so I was able to actually use a different technology. So caller endpoints are there, they're available, they're tested, they work. And so is launch remote actor. Launch remote actor, as I said, initially required an experimental fork of actor framework. That has been resolved. Launch remote actor now reaches out and just uses a straight up installed version of actor framework. And for the web service, it actually gave us a much cleaner, easier to understand solution to this exact same problem, which is why we use it in the web service. Launch remote actor, again, occupies this PFM space. And what it does, what it puts in that space is a VI called launch remote actor, which does some stuff under the hood. And the stuff under the hood is moderately complex. I have a couple of slides on that that I'm not going to share in session. If you're curious, find me offline. I'm happy to share. It relies on VI server calls to make that connection and to create that bridge across the application boundaries. Okay. All you see as a user of launch remote actor is this VI. Just the one. You can see why I was kind of excited about it. Launch remote actor looks almost exactly like it, you use it exactly like you would use launch nested actor. The difference, of course, is you need to have an application reference. So what you're saying is launch a nested actor over there. Using it is about that simple. Okay, you have to have, there has to be a running version of LabVIEW out there. So for the CI service, we had to create some stuff to launch LabVIEW. But once it was launched, we just had to get a reference to it, and we were good to go. So what does that look like when it works? Well, you need to have an instance of LabVIEW up on the remote target. Okay, so you can do that yourself. And that instance of LabVIEW, which could be a dev environment, could be an executable, has to have a few things forced into memory. I will tell you what those are in a minute. But it doesn't have to do anything. There's no endpoint sitting there waiting for a connection. It's just a sort of a blank LabVIEW page waiting for you to write to it. The host launcher will launch its local process, which will just reach out across the network and launch a remote, as far as you're concerned. There's some stuff that happens that you don't see. And that launches a sub-process in your business. Okay? The things you have to load in memory. You need to have the actor you want to launch remotely needs to exist in memory in both target and both targets. Any other classes you're going to send, of course, just like we talked about, there are two VIs that get called through VI server that are part of the launch remote actor package, and you need to have them in memory available on your second target. Coupling's a little more complex. Okay? From nested to caller is what we've been talking about. You'll have that abstract UI is just an interface class, like we talked about, and it will have an abstract proxy child that has the local code. On the nested side, on the lower side, though, the way this works is the caller has to be statically linked to the actor that's going to be launched on the nested. Okay, you can't decouple that the way this works. So what that means is that's probably going to be kind of interface class on its own. What it's going to do is it's going to dynamically launch its sub-processes if they call stuff that you can't have installed locally. That probably means that you're talking about giving, this sub-process some abstract parent and doing some decoupling there as well. So this gets a little more complex. Now, what we found with the CI web service was that it was all LabVIEW post-side code, and we actually didn't mind having it move in the same target. There wasn't as much of a need to decouple as we found. Again, if you're calling RT code, that'll be different. That'll change. Okay, so which do you use? I've given you two solutions, and you'll pick the one that you like best for the problem at hand, as with all things. The launch remote actor API is as simple as anything that actor framework is. But you have an easier time. The cost of that is you have to do a little more work on code decoupling, whereas caller endpoints code decoupling is fairly straightforward. Launch remote actor only uses VI server, which has its challenges. You can't secure it. IT guys don't like to let it pass through firewalls because you can do all sorts of mischief. So if your environment may not permit you to use it, and that will push you back to caller endpoints. So why would you buy all that? Why would you buy all that extra difficulty? Well, you buy that extra difficulty because with caller endpoints, you launch an endpoint, and it's going to launch an actor, only one, established at edit time. And you're stuck with that one. So if you want to have more than one actor available, you're going to have more than one caller endpoint running. And that may not be a desirable model. Launch remote actor lets you just launch whatever actor is already in memory over there. And so you can have different actors in the same tree. So again, it's going to make your code simpler in some ways. Pick the one you need. We've had some conversations about how you could actually push the nested actor across the network from the caller. We haven't worked all of that out yet. So that may happen in the future. Do you use a pair of linked actor trees, or do you use a single InterTarget tree? Again, depends on the need. If you're linking two trees, it's nested endpoints. InterTarget, of course, is caller endpoints or launch remote actor. Linked trees give you a client-server architecture. If that's what you want, use linked trees. A lot of applications want that, prefer that. But if you want to play with that distributed actor hierarchy, that's what the other two options are for. And what's going to drive that difference is going to be things like, well, my client connects intermittently. I need the serial code running all the time, but I only want to look at UI once in a while. Okay. Flip side is the caller determines the life cycle of the nested code, which can be intermittent, and that can be a really useful and powerful thing. So you'll pick the ones you need for the job at hand, as with all things. Now, hopefully I got you excited. Hopefully you're like, okay, I'm great. You talked. Where do I get it? Where do I get it? Yeah, get it on the LabVIEW Tools Network. Yay! Everything I've talked about here is available on the LabVIEW Tools Network. Take a picture of it. Next slide. Call up the Package Manager. Search for the term actor. You'll get all of these. You'll get a few more as well. Some other folks who look for the ones on the Tools Network. Network endpoints and launch remote actor are packages. You get the examples separately, but they're also available. Go ahead and grab them and download them. If you want a little more information, you can go to their original posts on the Actor Framework forums. Those are good for a little bit more background. Just Google these names. It's the easiest way to find them at this point. You can go to those original pages. You can see the original commentary on them. Some notes, some updates, all the comments from people that have used them. So some of your pain points, if you have any, might already have been discussed. There are earlier versions of the packages there, but they're not we're not updating those. All the updates are going out to the tools now. So while you're filling out the survey, I'll take questions. No questions. All right, no questions. Well, hopefully you'll go out and play with these guys. And yeah.
How do you serialize your messages over the CIP?
Flatten the string. Flatten the string, and then unflatten the string. And that's why you have to make sure the message is loaded on the other side, because the unflatten is just to a basic message class, so you can put it onto the impure. And LabVIEW doesn't have the actual message loaded, won't know how to handle it except as a basic message. So an interesting bug that comes up is, how you'll know you're not putting a message in memory is it works in the dev environment, you'll do a build, and it's now looks like your actor's not getting any messages. So I'll take...
What version of LabVIEW do you go back to?
Caller nested endpoints go back to 14. There's a bug in the caller endpoints that I just fixed for 15, but I didn't go back and fix it for 14. If anybody really wants me to fix it for 14, I'll PM me on the forums and I will make that happen. But I don't have 14 load. I need to put 14 on a VM and do that. And so I can put that off. If it doesn't need, I'll do it. It's also a really easy fix. So basically, yeah, soon 15 and later. Launch mode actor, I think, goes back to 14. Certainly it's 15.
Do you have any best practices for making sure that both sides are referring to like the same version of your messages and stuff for like classification?
Not yet.
Okay.
No, not yet.
All right.
That's yeah.
Do any of these methods handle things like managing the state of the connection, the remote connection, and handling if it breaks unexpectedly?
When it breaks unexpectedly, so the VI servers just VI server calls. If they break, they just they break, but you'll reestablish them by just reaching out again. Caller nested endpoints. If they run on TCP/IP, you get the TCP/IP stuff. You get some buffering off of network streams. I think I do a flush if they disconnect, if I recall correctly. So you might drop some messages.
So if the caller endpoint's running and the connection's down, does it know somehow that the connection's down? Or does it
Yes.
just keep doing it?
Yeah, because the network streams and the TCP connection will fail, and you'll get an error out that the connection is lost, and that suffices to. And then of course we handle the error by killing off the actor. So you'll get that feedback that'll show up as a in the last act state of the endpoint. Anything else? All right. Have a good night. Anybody wants to talk to me offline? I've got a couple minutes to take questions, and John and I have to go next door. And really, if you have questions, just come get my card, and then I'll catch up with you. We have a session in 10 minutes. Thank you.